Hello. This video is for the IXL activity titled Graph Solutions to Absolute Value Equations. The three-character code for this activity is Kilo X-ray Alpha. At the time of this recording, this activity can be found in the Algebra 1 section, Section L of Algebra 1, and it's Activity 2 within that section. So absolute value equations. Well, one thing we have to remember is that absolute value is all about the distance from zero on a number line. For instance, -5. Even though it's -5, it's a positive 5 units from zero, so the absolute value of -5 is positive 5. And likewise, on the other end of the number line to the right of 0, 5 units is positive 5. So -5, positive 5, they both have the same absolute value. They're both 5 units from zero in that case. So we realize that whatever's inside of this absolute value portion of the equation, that it can equal something that's positive or it can equal something that's negative, either one. And then we have our solution. We have what's on the other side of the equation there. So in a previous activity where we did some of these problems, we went ahead and realized that we need to first isolate the absolute value portion of the equation, in this case, like the absolute value of p plus 1, get it isolated all by itself on one side of the equation, and then we'll have an answer on the other side. And we also learned in a previous activity that if we have it isolated on one side and there's a negative number on the other side, then there is no solution to that equation, because whatever is inside of this, whenever we pull it out, we take the absolute value, whatever's inside of the absolute value brackets there, that it comes out as positive. So if we saw a -5 there, we realize, hey, there's no solution to this problem. If we have the absolute value portion isolated on one side and over on the other side is a 0, well, 0 is neither positive nor negative, so we would only have one solution. So whenever we have something like what we see here, where we have the absolute value of p plus 1 isolated on the right side of the equation, and then on the other side of the equation we have a positive number. If that's the case, then we know that we are going to have two solutions. So let's go ahead and work this out, find those solutions. And in this activity, instead of actually entering the number values for our solutions, we're going to go ahead and plot those on number lines. And so we'll see what that's all about as well. All right, starting off on my first problem here, I like to rewrite my problems, right? 5 equals the absolute value of p plus 1. And now the p plus 1, the absolute value of p plus 1 is already isolated on one side. So hey, let's go ahead and create those two equations that we need to do, realizing that what's inside of here can either equal -5 or positive 5, right? Because whenever it pops out of that absolute value, it's going to become positive anyhow. So whether we have positive 5 inside of the absolute value or we have -5, either way it would equal positive 5. So our two solutions, what we're going to do is, after we've isolated this absolute value portion of the equation, we're going to take what's inside of that absolute value portion, put it on one side of the equation. So let's go ahead and do that, p plus 1. And then we're going to set that equal to both the positive version and the negative version, meaning that we're going to have two equations, which makes sense because we're looking for two solutions, correct? So I always like to do the positive version first. And then over here, I'm going to do p plus 1, again, taking what's inside of the absolute value portion and pulling it out to start an equation. And then we have the negative form of it is -5. Next thing we do, hey, let's solve for p in both cases. So p plus 1, I need a -1 to get rid of the positive 1. And what I do to one side, I do to the other. Positive 1, -1 is going to cancel each other, leaving just p on the left. And then 5 minus 1 is 4. So my first solution is p equals 4. Over here with the second equation, the one that's in the negative form, the -5, let's go ahead and subtract 1 from each side. And the ones will cancel each other, leaving it just p on the left. And then -5, and then I subtract 1 from it. That's like adding a negative integers, right? So -5, -1, it's just going to get more negative. 5 plus 1 is 6. So my second one is -6. And right now I'm distracted because I'm thinking I circle one solution and I draw a box around the other solution. Why I do that, I do not know. So let's go ahead and graph those. So let's find 4 on the number line. There's 4. So on IXL, you just click right there. And whenever you click that, I'll put a dot there. And the other one's -6. And so we click here and we get -6. Now, a little bit of advice on this activity. If you get a solution and the solution's not on the number line, then chances are you've got the wrong solution. Go back, check your work. And again, like I encourage my students all the time, work this out on paper. Don't try to do it in your head. Grab a sheet of paper and work through each of the steps to keep all those numbers lined up. Make sure you're following all the steps. That way, if you do end up with an answer that's not represented on the number line, then you can always go back and double check your math if you've got have it all written out, and you can look and see, okay, where might I have gone wrong on this problem. Let's move along to the next one. And here we have the absolute value of b minus 9 equals 0. Well, what do we know about if it equals 0? Well, there's no positive and negative form of 0. There's just 0. So instead of two solutions, we're only going to have one solution. So let's go ahead and write this out. As a matter of fact, I'm going to go ahead and just skip this step of rewriting. I'm just going to take what's inside of the absolute value portion because the absolute value is already isolated on the left side. So let's go ahead and pull that out and do that b minus 9. And we'll set that equal to 0, right? It's because we're only going to have one solution because there's no positive and negative 0. There's just 0. Let's add 9 to isolate that variable b. And what we do to one side, we do to the other. Negative 9, positive 9 cancels each other. Leave b on the left. And 0 plus 9 is 9. Therefore, my answer is b equals 9. So let's find that on the number line. And in this case, we only have one solution because after isolating the absolute value portion of the equation to one side, which was already done for us, we have a 0 on the other side, so we know that there is indeed only one solution. On the next problem, here we have 50 equals 20 minus d. Oh, it's the absolute value of 20 minus d. So over on the right-hand side, the absolute value of 20 minus d is already isolated for us, so we can go ahead and write our two equations. And I like that 20 minus d, that variable portion. I like it over on the left and start with that. So I'm going to go ahead and do that. I'm going to write a positive form of the equation and a negative form of the equation and solve for the variable d in both cases. So on the first one here, I'm going to put 20 minus d. Remember, I'm just taking what's inside of the absolute value there and pulling it out, creating an equation with it. Here's my positive form of the equation, and then I'm going to do a negative form of it, 20 minus d, again, from what's inside of the absolute value portion, and then negative 50. So I have a positive version, positive 50, and a negative version. I'm going to solve both of these. So I have positive 20 here. Let's subtract 20 from each side, and what we do to one side, we're going to do to the other. The 20s will cancel each other, and I end up with negative d. Remember, this minus d is actually plus a negative d, so it's negative d that we have to bring down. 50 minus 20 is 30. And now I need to go ahead. This can't be negative d, so it has to be a positive d, so I'm going to divide by negative 1. That means that'll work out those negatives there. It'll cancel each other. D over 1 is d. And 30 divided by negative 1 is, well, negative 30, because positive divided by negative is negative. So my first solution is d equals negative 30. Now over here on the other side, let's go ahead and subtract 20 from each side. The 20s will cancel each other, bring down that negative d there. And remember, this is like 50 plus negative 50 plus negative 20. And so that's going to be what? Negative 70, right? Let's go ahead and divide by negative 1. We do to one side, do to the other. The negatives will cancel each other out, leaving d on the left. And negative divided by negative is positive. And 70 divided by 1 is 70. So my second solution is d equals 70. Let's make sure both of those solutions are represented on the number line. First, negative 30. There it is right there. And then 70. So I must have done all right on these. Plot those two, click submit, and move along. Okay, on the next one here, notice that I have this negative 5 right here that's not inside of the absolute value portion of the equation. That means I have to eliminate that negative 5, isolate the absolute value portion over there, in this case on the left side of the equation. Then from there, I can go ahead and work with that. So let's rewrite absolute value of w minus 20. And we're going to go ahead and subtract 5, set that equal to positive 5. So the 5 is tied to the absolute value portion that we want to isolate through subtraction. The opposite operation is addition, and we're going to add the very number we wish to get rid of. And what we do to one side, we're going to do to the other. So on this one here, negative 5, positive 5 cancels each other, leaves me with absolute value of w minus 20 equals, and 5 plus 5 is 10. So now I've isolated the absolute value portion of the equation on the left side of the equation. It could be on the right, but in this case it's on the left. and I have it equaling a positive number, so I know there's going to be two solutions. So let's go ahead and work those out. So over here on the left, I'm going to set up my positive form of that, W minus 20. Again, taking just what's inside of the absolute value portion and set that equal to positive 10. And let's separate all that off there. And then we'll work the negative one out over on this side over here. So W minus 20, again, what's inside of the absolute value portion. And then we want the negative form of the answer. So instead of positive 10, we're going to make it negative 10. Let's work those two out, get our two solutions. W minus 20. So let's add 20 there to get rid of that negative 20. What we do to one side, we're going to do to the other. Those 20s cancel each other there. Leave me with W on the left. And 10 plus 20 is 30. So my first solution is W equals 30. Let's go ahead and add 20 to get rid of that negative 20. And what we do to one side, we're going to do to the other. The negative 20, positive 20 cancels each other, leaving us with W. And negative 10 plus 20, well, that should give us, what, a positive 10, right? So W equals 10. So let's see if we have those two values on our number line here. Indeed, 10. Here we go with there with the lesser of the two. And then the greater of the two is 30. So 10 and 30 are our two solutions. Let's move along to the next one. Looks like our numbers are getting a little bit bigger. Maybe I've got to do a little bit of math there, but other than that, we're going to follow the same process. Whenever you get to these questions where the numbers become in the hundreds or you get decimals, again, just keep following the process and work through the math till you come to the solution. So with my rewrite, I'm going to go ahead and put 16 equals absolute value of P plus 335. And to that, I need to add 1. All right. I need to isolate the absolute value portion of the equation. It has a positive 1 to it, so let's go ahead and subtract 1. What we do to one side, we'll do to the other. That's going to get rid of that positive 1 over here on the right, correct? Which works towards our goal of first isolating the absolute value portion of the equation. So with that said, 16 minus 1 is 15. And now we have the absolute value of P plus 335. Now I'm going to set up two equations. One where it's P plus 35 equals positive 15. So let's go ahead and do that. P plus 335 equals a positive 15. And again, let's go ahead and grab that there. Let's section that off there. There we go. Actually use a line. Looks a lot neater that way, don't it? All right, so, and let's make our negative 1 before we get started. P plus 335. Like I said, work these out on paper, and I do it the same way every time. I isolate that absolute value on one side, then I create my positive equation, create my negative equation, and then I go back, work one equation, and then work the other till I get both of my solutions. So in this case here, we need to subtract 335 from each side. And so minus 335, so it's actually like plus a negative, right? The 335 is going to cancel each other, leaving just P on the left. However, the 15 plus the positive 15 plus the negative 335, so I am adding a positive and a negative integer together. So that means I actually want to subtract. So 335 minus 15 should be 320. And of the two, the negative 335 has a greater absolute value and it's negative, so my answer is going to be negative as well. So it's a negative 320. P equals negative 320. Now over here, I'm going to go ahead and subtract 335 from each side. So minus 335 on each side. Remember, this is like adding a negative. So now I'm adding two negative numbers. It's going to get even more negative. So with that said, I'm going to end up with a negative number there. But before I do that, I'm going to go ahead and cancel this stuff out here. Put my P over there. And then I'm going to end up with 335, 45, 50, right? 350. So looking for those two solutions on the number line. P equals negative 320. Indeed, there's one of them. And then negative 350. That number is there as well. So I'm good to go. I must have done my math right. All right. Next one here. Oh, look, it equals 0. So what does this mean? There's only going to be one solution. So we've already got the absolute value portion of the equation isolated on the right. So let's just go ahead, grab what is inside of that absolute value and set up our equals 0 equation. So 4r minus 400 equals, and all that equals 0. So since it equals 0, there's only going to be one solution. So with that said, let's go ahead and add 400 to each side. And the negative 400, positive 400 cancel each other, leave me with this 4r. We're going to go ahead and bring that 4r down. Equals 0 plus 400 is 400. Now the 4 is tied to the r through multiplication. The opposite operation is division. Remember, every fraction is a division problem, so I'm going to use a fraction bar. I'm going to divide by the very number I wish to get rid of, which is 4. And what I do to one side, I'm going to do to the other. Those 4's cancel each other, leaving me with r. And 400 divided by 4 equals 100. Is 100 here on our, indeed it is. Go ahead and plot that point, click submit, and move along. All right, here we have to go ahead and deal with that negative 4. So let's go ahead and do that. Rewrite our problem. 4 times the absolute value of d minus 70. And all this equals negative 80. Well, it's like, wait a second, it equals a negative number. But look what happens whenever I divide by 4, because I'm trying to isolate the absolute value portion of the equation. And what I do to one side, I do to the other. The negative 4 is going to cancel each other, leaving me with the absolute value of d minus 70 equals negative divided by negative. Bingo, it's positive, right? And what 8 divided by 4 is 2, and throw that 0 back on there, so it's going to equal 20. Now I've isolated the absolute value portion of the equation on the left-hand side. I got it equaling a positive number on the right-hand side, so that means I'm going to have two solutions. So let's go ahead and set up our two different equations. D minus 70 equals a positive 20, and on the other side, D minus 70, and I want that to equal a negative 20 over there. And again, go ahead and separate this off nice and neat with a couple lines to keep our work separated there. And then let's add 70. What we do to one side, we do to the other. We're adding 70 to get rid of that negative 70 there, right? Those cancel each other out, leaving it D on the left, and 20 plus 70 is 90. And as I write my answer, I glance up there and I see, oh, yep, 90 is there, so I'm good to go. And then add 70 over here and add 70 over here. And so in this case, those 70s cancel each other out, leaves them at D on the left. Now I'm adding two integers together in which one is positive, the other one's negative, so I actually want to subtract. 70 minus 20 is 50, and 70 has a positive 70 has a greater absolute value than negative 20. So since it's positive, my answer is going to be positive, so my two answers are 50 and 70. Let's go ahead and plot those on the number line. Here's 50, and here's 70. We'll go ahead and click that submit button and move along to the next question. And here I have negative 81 equals negative 6 times the absolute value of 15 minus r. And to that we have to add 9. So we got a few steps here to do, right? So we've got this, we got to get this absolute value of negative 15 minus r by itself. That is to say we have to isolate it. But it's being multiplied times negative 6. But it's also being, to that value is being added the value of 9. So we need to undo the addition before we can deal with that multiplication over there. So let's go ahead and subtract 9 from each side. And where's my equal sign? Yep, there we go. Make that equal sign a little more clear there. So with that said, this is like plus, right? So negative 81 plus negative 9, it's going to get even more negative and be negative 90 equals, let's bring down our negative 6 times the absolute value of 15 minus r. The 9's cancel each other. Now the negative 6 is tied to the absolute value of 15 minus r. Through multiplication, we're going to divide by the very number we wish to get rid of. And what we do to one side, we're going to do to the other. So those negative 6's will cancel each other out. On the right, we've now isolated the absolute value of 15 minus r. And negative divided by negative, positive, which is good because we need a positive number over there. And 90 divided by 6, I believe, is 15, correct? 6 times 10 is 60, 6 times 5 is 30, 60 plus 30 is 90, so indeed it is 15. So now I need to set up my two separate equations. I'll put my little divider line there so we can kind of keep our math separated. And we're going to set this up as 15 minus r, just taking what's inside of the absolute value portion, set that equal to the positive form of it, positive 15, and then on the other side, 15 minus r equals, and then the negative form of it, negative 15. Let's go ahead and subtract 15 from each side. And what we do to one side, we do to the other. And this one's kind of interesting, right? Get rid of those, and we end up with negative r equals, and 15 minus 15 is 0. And then whenever we divide by -1, that gets rid of the negative, makes it r equals, and 0 over -1 still equal to 0. So my first solution is r equals 0, and indeed it's up there on the number line, so I'm good to go. And then on the other side, let's go ahead and subtract 15 from each side. Remember, that's like adding a negative. So those cancel each other. We bring down, remember this is a negative r, that's plus a negative r. So that's actually negative r when we bring it down. Don't forget the negative sign. And we're going to get -30. And the next step, divide by -1. What we do to one side, we do to the other. Negatives cancel each other out. We end up with just r. And negative divided by negative is positive. 30 divided by 1 is 30. And so there's my second solution there. So my two solutions are 0 and 30. Good to go. I think I should just have maybe one more question here, hopefully. Yep, indeed, this is the last one, so we're just about home. -49 equals -2 times the see, I want to say quantity of because I'm thinking of it as parentheses. Those are not parentheses, they're absolute values, so I'll correct myself. -49 equals -2 times the absolute value of 2y plus 20, and from that we're going to subtract 9. So let's go ahead and write all of that out and just follow it step by step. Again, be sure to be working these out on notebook paper. I think it's a good idea to keep a notebook, and that way whenever you go ahead and look back and kind of study for it and refresh your memory, you got all your problems there that you could sort out. Put all of our problems in one book. Sound like a psychiatrist. All right, before we can deal with the multiplication of -2 being multiplied times the absolute value of 2y plus 20, we have to deal with the subtraction over here. So we're going to go ahead and add 9. What we do to one side, we're going to go ahead and do to the other. -49 plus 9. Well, actually, one's positive, one's negative, so we're really going to subtract, and we get 40. The -49 has a greater absolute value, and it's negative, so our answer is going to be negative. And then let's bring down that -2 because the 9's cancel each other. -2 times the quantity of 2y plus 20. Now let's go ahead and divide by that -2 to get rid of that there. What we do to one side, we're going to do to the other, which works out really nice because that's going to give us a positive 20 over here, right? We want that to be positive. Those -2's cancel each other, leave me with the absolute value of 2y minus 20. And now I can create my two separate equations. So we'll go ahead and do that. We'll put the +1 over on the left and the -1 over on the right. Let's go ahead and do that +1 first. Pull what's inside of the absolute value portion is one side of the equation. And we're going to set it equal to the +20. And then over on the other side, we're going to pull that portion, that 2y minus 20 out of that absolute value there. And we're going to create the negative version of it as well. So let's work out the positive side, then we'll work out the negative side, and that'll pretty much get us through the end of this last question here. Let's go ahead and add 20 to get rid of that -20 there. What we do to one side, we're going to do to the other. Those will cancel each other. Going to leave me with 2y on the left, and 20 plus 20 is 40. Now let's go ahead and divide by 2. And that leaves us with y on the left, and 40 divided by 2 is 20. And as I look up here, yep, 20 is on the number line. Good to go there. So that's our first solution. Second one over here, let's go ahead and add 20 to each side. This is going to be nice because those cancel. Leave me with 2y equals 20. -20 plus 20 is 0. Now, whenever we divide by 2, almost really shouldn't have to write it, but I'll go ahead and work it out. 2's cancel. We end up with y, and 0 over 2 equals 0. So our second solution is y equals 0. Let's plot those 2 points out. 0 and +20. All right, not too shabby. Okay, so that concludes all of my examples for the IXL activity titled Graph Solutions to Absolute Value Equations with the 3-character code of Kilo X-Ray Alpha. Good luck with your activity.